Good morning. Let's try that again. So, good morning and welcome to STEAM Livestream. I'm Professor Gruff, and today we're going to talk about gas. So we're going to talk about when I blow up this balloon. And it's gone. When I blow up that balloon, I'm forcing air into the balloon, and that causes it to expand. And so we're going to talk about what's going on inside the balloon, and we're going to talk about the relationship between pressure when it comes to a gas and volume. So I increase the pressure in the balloon, the volume increases, and temperature. So I'm going to start with a demonstration. We're going to do some observation. And when we do some observation, we're going to look at relationships between these three things: pressure, volume, and temperature. All right? Okay. So let me move my camera here. All right, so I have an apparatus here, right here, and I'll turn it on. And so what I can do with this apparatus is I can control two things and measure temperature. So what I have here, this is a temperature. This is a thermometer. Right, here's a thermometer, and it's measuring the temperature of the air inside of this cylinder. All right, this is a pressure gauge. It measures how much pressure the gas in this cylinder is under. And on the side of the cylinder here is, I know it's hard to see, is it's a graduated cylinder, and you can measure volume. So this cylinder has a, I'll show you a little higher. It has this screw, and if I zoom in really close here, you'll see as I turn the screw, the plunger goes up or the plunger goes down. All right, so what that allows me to do is control the volume of the cylinder. In other words, how much gas is, how much space is in here. So if I twist this, I'm decreasing the volume, the amount of space in the cylinder. If I twist it this way, I'm increasing the space. All right, so let's go over here. So this pressure gauge has a needle, and right now it's measuring about 14 pounds per square inch. That's atmospheric pressure. Stop calling it a plunger. What should I call it? Anyway, so this gauge right here, and there's a little valve here, and I can close the valve. And when I close this valve, what I've done is let me back up here a little bit. I've made this a closed system. There's gas in here, and the gas, when I put the plunger down, the gas would want to escape through a little tube that's connected over here out this little valve, but it can't. It can't escape because I closed this valve. All right, so time to make a prediction. All right, I'm going to watch your comments and see what you say. And what I want you to make a prediction about is if I turn this plunger, if I turn this these screws so the plunger in the cylinder goes down, what's going to happen to the pressure inside the cylinder, the pressure of the air in here as I make the space smaller. I'm looking at your comments to see what you say. Less talking, more learning. Well, I'm going to have, while I'm looking at your comments, check out my Stirling engine teacup going away. I'll have a couple sips of Stirling engine tea while I'm looking at up, 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 up. Okay, so I actually see some predictions now. So you guys are predicting that if I turn this this screw and make the plunger go down, the needle will go up. And you're right. So as I decrease the amount of space, the pressure goes up. So this is like trying to force the gas into a smaller and smaller space, and the amount of pressure it's under goes up. All right, I'm going to do it quickly, and let's see if you notice anything else. Do you notice anything else happening as the pressure goes up, as the volume goes down, and the pressure goes up? Anything else? What do you notice? The temperature is going up. Somebody's got it. So as the pressure, as the volume goes down, the amount of space goes down. What I'm doing is I'm compressing the gas, the air, into a smaller and smaller volume. That makes the pressure go up, but it also makes the temperature go up. So these three things are all related. You want to see my Stirling engine, don't you? All right, that's just too distracting. I need a sip of my Stirling tea. Ooh, hot, hot, hot tea. Put that over here. All right. All right, so if I release this valve, I'm going to let all the air out, and the pressure goes back to normal, the normal air pressure in this room. All right, now I'm going to close it, and I'm going to turn this the other way. So now what I'm doing is I'm giving the gas that's in this cylinder more space to spread out, and see the pressure drops. The pressure drops. And the temperature drops too. So there's a relationship between pressure and temperature and volume. They're all interrelated. All right, so now we're going to go to a simulation, because I want to talk about what's going on here. So what exactly is pressure anyways? What is air pressure? So I'm going to go to a simulation. All right. And in this simulation, what I can do is, so I have a container. This box represents a container, so it's like the cylinder in the demonstration I just did. And there's a pressure gauge, so I can measure how much pressure is inside this container, how much temperature, what the temperature of the gas is, and I can also change the container's size or volume. Okay, so I can control volume, I can control temperature, and then the other thing I can do is add gas. And you're like, well, that doesn't look like gas. And so what do I mean I've added gas? Well, what is gas? Gases are molecules. Most of the molecules in our atmosphere are nitrogen molecules. And then the second most abundant kind of gas is oxygen. So you got nitrogen and oxygen. Here, how about if I add some different gas molecules, different sizes. But what you'll notice is, so molecules, you can think of them as little tiny balls bouncing around. Okay? And these little tiny balls are zipping around at very high speeds, but they're so tiny you can't see them. And there's so many, we don't feel them as like individual little particles. But the gas in the room, the air that you're breathing, are little tiny molecules. So we can conceptualize it like this. Okay. And so what exactly is pressure? Well, if gas are these little tiny balls bouncing around, pressure is the collision between the balls and the sides of the container that they're in. So air pressure is this thing that we feel because gases are zipping around and bombarding things that they come in contact with. And another way of thinking about that is pressure can be thought of as how frequent these little collisions are between the gas molecules and the sides of the container. So how can we make those collisions more frequent? Make the box smaller. Now you're cramming more stuff into a smaller space. And anybody who has brothers and sisters knows when you try to put brothers and sisters in a small space, there's more pressure. There's more collisions. There's more interactions. And so pressure goes up. Make the container larger, and pressure goes down. All right, what about temperature? Let's heat up the gases. What do? You heat up the gas molecules and they go faster. They bounce around faster, and the pressure goes up. What if we cool them off? We cool them off and the pressure goes down. Why? Because they slow down. The gas molecules slow down. So it's all connected to what these molecules are doing. All right. So let's see. I'm going to watch your comments, but while I'm doing that, I'm going to switch over to a different screen because I want to write something out here. Okay. So I want to write out a summary of what we've learned here. So what we've learned is we have pressure, volume, and temperature. When we're talking about gases, these are three ways of describing the properties of the gas. How much pressure is it under? How much volume is the container? And what is its temperature? So I'm looking at the comments while I'm writing here, and I'll try to answer some of them. So someone asked, what's the difference between the two types of molecules in my simulation over here? Someone says, what's the difference between the reds and the blues? And in the simulation, the only difference are the reds are smaller than the blues. So this would be like, I'll give you a real example. So there's different kinds of gases. Oxygen and nitrogen gas are molecules that are pretty small. And then there's other types of gas like argon, which are much heavier. And microscopically, you can't see these things, but microscopically, if you think of these atoms as little balls bouncing around, at a given temperature, the smaller molecules are moving faster than the bigger molecules, and that's what the simulation is showing. All right, back to the screen. Okay, so what I want to do before we end today is I just want to someone says, why are they at different speeds? The blue and the red balls. It's because they're different sizes. There's a more sophisticated physicsy answer to that, but that will have to wait until you're in high school or college. So if I call pressure P, volume V, and temperature T, just for short, what we can do is we can summarize the observations that we made today to write down relationships between these quantities. All right, and okay. So we have pressure, volume, and temperature. Okay. And one of the observations we saw was that if I made the volume smaller, what happened to the pressure? I'm going to look at your comments. When we made the volume of the cylinder smaller, someone says make a summary video. More pressure, I'll draw it like this. So as the volume got smaller, the pressure went up. Good. Let's erase that. As the volume got smaller, the pressure got bigger. You could write it like that. Another thing we saw, as the volume got smaller, the pressure got bigger, and the temperature got bigger as well. So if we put all these things together, we see there's a relationship between pressure, temperature, and volume. That holding other things relatively the same. If you increase pressure, you're going to increase temperature. Or if you decrease pressure, you'll decrease temperature. And we call that, so let me clear the canvas here. So when we have a relationship, here's a little bit of a math lesson. If there's a relationship between things, so that if one gets bigger, the other gets bigger too. I should do that in red. So if pressure gets bigger, temperature gets bigger as well. What we say are those two things are directly related to one another. If one gets bigger, the other one gets bigger. Or if one gets smaller, the other one gets smaller. All right? So a relationship like this is a direct relationship. Okay. On the other hand, we saw that as volume got smaller, pressure got bigger. Right? So as volume got smaller, pressure got bigger, and so what we call that is, in math, we call that an inverse relationship. Sorry, my writing is kind of bad today. It's better than last time, though. So two things are related in a way that if one gets bigger, the other one gets bigger. We call that a direct relationship. But if they're related in a way that if one gets bigger, the other one gets smaller, they're called an inverse relationship. So I'm wondering, do any of you have, clear this canvas. All right, I'm coming back to the webcam. All right, so let me finish up today. I'm going to look at some of your comments. All right, reading some of your comments. And I'll see if you have any questions. I know there's a lot of information. Who is Amanda Groff? You mean Miss Groff, the art teacher at Shepherdstown Elementary? I saw, so some of you I saw as I was doing this, I saw at least one of you write a relationship on the screen, a mathematical equation, which was PV equals nRT. And that's called the ideal gas law. And so mathematically, you can summarize all these relationships between pressure, temperature, and volume using this mathematical relationship called the ideal gas law. But I like this, we're just talking about things conceptually here today. We don't have to be too we don't have to try to quantify everything. That's good tea. All right, cool painting behind you. Yes, the airbrushed bobcat. Any other questions for me? PVT. Did you learn anything today? Yeah, I like the cat, yes. So these relationships between pressure, volume, and temperature, humans are very smart. We're able to figure out how the universe works, and then we can use our understanding of how the universe works to build useful devices. And how many of you have air conditioning? Most of you probably. Well, air conditioning is based on these principles. And it's based on the idea that if you have, where'd my balloon go? If I have a balloon, and I allow the gas in this balloon to expand quickly, so I allow its pressure to drop and its volume to increase very quickly, what happens to the temperature? It drops. And that's how you can have an air conditioner. All right. Okay, so I'm gonna wrap it up because I gotta go do some more work. I will be back on Friday at 10 a.m. and we'll do another live stream. And starting next week on Monday morning, I'm gonna start doing lectures for my physics class at Shepherd University, and I'll have commenting turned off for everyone except for members of that class, but you can still watch. So this is a college level physics class. I'm going to start lecturing to them, and you're welcome to join in, and you'll get a little taste of what college is like, what college physics is like. All right, so if you see a live stream pop up at 8 a.m. on Monday, that's my physics class. And then at 10 a.m. on Friday, that's the next time I'll see you, and I'll do another live stream. All right? Okay, until then, well, I'll see you then. All right.